Hi everyone, my name's Shaun Abram, like Kirsten said, and I'd like to start by thanking Kirsten for inviting me to speak today. I really appreciate it. And to Tiffany for helping me get set up. So the talk today is testing in production. And you may have seen this meme before. Pretty old one. The Dos Equis guy saying, I don't always test, but when I do, I test in production. And testing in production has kind of been a joke, right? The joke being that when you say you test in production, what you really mean is you don't test at all. You just push it out to production and you cross your fingers and you hope that it works. You're winging it, basically. Recently, though, I've been starting to think about this slightly differently. So the original ad is the Dos Equis guy saying, I'd always drink beer, but when I do, I drink Dos Equis. The implication being that Dos Equis is the best beer. So rather than this being a joke, is the implication that production is the best place to test. And I'm increasingly starting to think that that's the case, or at least that you should be considering testing in production. But historically, production's kind of been treated sacrosanct. Instead of testing there, you set up a bunch of other environments, such as staging, that are as similar to production as you can make them. But that's not ideal, because there's always going to be an imitation of production, never quite like it. And so testing in a non-production environment is kind of like testing with mocks. Close, but not the real thing. And saying that it works in the staging environment is just one step better than saying it works on my machine. I saw someone, Charlie Majors, on Twitter say that software going out to production is like a baby's fourth trimester, when the software hits the harsh reality of the real world. But the question is, why is the real world of production so different? So serious question. How is production different from all the other environments? Any suggestions? Yeah, Jerry. Traffic is a great one. You're unlikely to see traffic in your non-prod environments like you do in production. For example, in non-prod, it's typically a few QA testers or maybe some artificial load test, right? What else in addition to production? Sure. I'm going to say the same thing. Data is another great one. Your data in the non-production environments is almost certainly different from production. For example, it should be scrubbed. You should be removing all of the PII data, right? So at Lending Club, I work on a service called the authentication service, and we don't have real passwords, real user passwords in the non-prod environment. We scrub them to be just a standard password. And so we've had problems in production where certain characteristics of passwords have caused problems, but we didn't see those in non-prod because all the passwords are scrubbed and standardized. So that's a great example of how non-prod is much different, and you may not catch problems there as a result. So we've got traffic, we've got data. What else? Yeah. Yeah, so you're probably, again, not storing those real credit card numbers in non-prod. At least you better not be, right? Yep, very true. You can't be doing both. And again, you may see some characteristics of the real data that you're not seeing in the scrub data. True. Did you have one? You are, because real customers are using it, and customers can be crazy, right? You're going to see a lot of different behavior. Hoster. But it's very true. So production is higher risk than non-production environment. It's true. There are many different ones. So we talked about traffic. We talked about data. Hardware is another one. Cluster size, for example. Typically in non-prod, you may have just a single machine. In prod, very likely to have more than one machine. And another big one that no one has mentioned so far is configuration. Guaranteed to be different in your production environment than it is in the non-production environment. Monitoring is another one. You probably have New Relic set up and tuned to perfection in your production environment, but yet in non-prod, you probably have a lot less monitoring too. So many different things about the production environment versus the non-production environment. And that's why some things can only be recreated in the production environment. So I'm advocating we test in production, but I want to make this point very clear. Right? Testing in production is not a replication or a replacement for testing in non-production environments. I've given this talk before. Some people came up to me afterwards and said, oh, so you don't think we need to test in non-prod anymore? And no, that is not the case. I want to be really clear about that. Testing in production augments or supplements the testing that you're already doing in non-production environments. I've given talks on unit testing and code coverage and mocks and continuous integration and integration tests. And all of those things are really important, and you should still continue to do them. I'm saying test in production also. And also I want to make this point that test production validation with respect to deserves validation because it's not explorative testing. All the testing we're doing in production is confirming that it works as you expect, not exploring different possibilities. With one exception, which is A/B testing. That is a form of explorative testing. I'll talk about it later. Second point is treat it with the respect that it deserves. Someone made the point that production has real impact, brand impact. If you mess it up there, you're really going to mess up customers, so tread carefully. When you're testing in production, think about the side effects. For example, it's okay to test with safe HTTP methods, such as gets. They're probably not doing a bunch of writes to the database. That's a good thing to test with. Even if you're writing with the non-safe HTTP methods, such as puts and posts, you can test those with faulty data, right? Bodies that you know are corrupted, and you expect to get a 400 back. That's a valid form of a test that shouldn't have too many side effects. And if you are testing with puts and posts with real data, make sure you have a way to distinguish the production data from the non-production data. For example, if you have reports saying how many users you have logging in, perhaps part of an IPO pitch, and those are inflated by test data, you're going to get yourself in trouble. So test in production. Treat it with respect, too. I'm going to break the talk into 3 different sections. Observability, which is the foundation for everything else, testing around release time, and then chaos engineering, which is testing after the release time. But let's start with observability, which is the foundation for everything else. Observability is the ability to ask new questions of your system without deploying new code. So you can think about it as a step beyond the kind of conventional monitoring and alerting that we typically do. Most of us are migrating to microservice environments, distributed architectures. Those are just inherently more complicated and inherently more difficult to debug and track. And the old vanilla monitoring and alerting sometimes isn't good enough anymore. Observability is taking it up to the next level. The reason we need to think about observability is that we need to accept this new reality of everything being more complicated and accept that everything is sometimes broken. Failure, you all know failure is not a question of when, it's a question of if. Everything will go down at some point in time. That's absolutely guaranteed. And the second point is that something is always broken. In any non-trivial system, it's not working at 100% healthy all the time. And if you doubt that, whatever log system you use, say Splunk, for example, go to it in production and type in, search for the word error and see how many hits you get. I guarantee you'll get hundreds or thousands, potentially a second, depending on the size of your application. Your application has errors all over the place. Sure, some of those are probably just poor log hygiene. They're not really errors, but some of them really are errors. And yet somehow we struggle on. And the reason is we're getting better at resiliency. We've got retry logic, we've got fallbacks, we've got caches, we've got sensible defaults. All those things help, but the reality is that something's broken all the time. And if it seems like something isn't broken, then your monitoring is broken. Because it is always broken. Just accept that reality. And the reality is that you can never guess all the different ways that your system is going to break. Lightning Club, we have about 450 microservices. You can take one of those microservices, test the heck out of it, deploy it to production, and suddenly it starts interacting with a host of others, and it's going to fail in ways that you never even possibly imagined. So we need to embrace that failure. So how do we do that with observability? How do we observe our apps? The 3 classic pillars of observability are logs, metrics, and tracing. I also think it should include monitoring and tools, so I'm going to talk about those a little bit too. But let's start with logs. Logs are kind of the most basic form, the thing that we're probably all doing since we started writing applications. But some things I'd like you to consider for logging are to use structured logging. I see a show of hands how many people are using structured logging right now. Couple, great. I'd love to talk to you guys after. This is something that we're exploring right now. For those of you that aren't familiar with it, rather than logging just plain text, structured logging is adding extra additional information to your logs, perhaps in JSON format, to be able to give you better debuggability and observability at runtime. So for example, most basic logging tools, such as Log4j or whatever your choice is, will give you things like the log level, the timestamp, maybe the process ID. Structured logging is taking that a step further and adding your own custom data to the log messages, such as a correlation ID or user IDs, whatever it is you need in production when stuff is going wrong to be able to quickly debug it. Rather than having to try and associate information later, you get it all in one structured logging statement. The second thing is event sourcing. For those of you not familiar with it, event sourcing is an approach where every event is stored as an event object, and that gets persisted to a data store, for example, Kafka or Kinesis. The idea being that you can recreate application state by replaying all those events at any point in time. That's a really useful source of debugging information. Knowing the current application state is good, but knowing how you got to that application state can really give you great insights into why your application failed. So consider event sourcing as another source of logging for debugging purposes. The final one is that sampling is better than aggregation. What do I mean by that? I think the best way to show it is as an example from New Relic. So this is a screenshot from one of our applications in production yesterday, and it's showing the average, I should probably get out of the way, huh? It shows the average response times for one of our applications, and everything looks really good, right? You can see that on average, over this 60-minute period, that all the response times are less than 80 milliseconds. I think that's pretty healthy. We defined our own update score of 200 milliseconds, and we've got 0.99. That means everything's looking really good. And even if we turn on the P99s, we can still see it's looking pretty good. So even the outliers, the P99s are still coming in at less than 350 milliseconds. To me, that's pretty good. Someone once stopped by my desk and told me that for this particular service, they were getting really slow response times, and I went and I checked these type of statistics. I'm like, oh, everything looks good to me. And I was dumb for doing that because aggregation and averages don't tell the true story. The good thing about New Relic is that it allows you to sample. And so if you scroll down to the samples, it shows you the 5 slowest endpoints, and it shows you the 3 slowest times for those endpoints. Suddenly you can see that we had a transaction that took 18 seconds. That's slow. That's the one someone's complaining about. And if I quote them that our average response time is 80 milliseconds, they don't give a crap about that. They still saw that it was 18 seconds. So again, sampling beats aggregation. Of course, the big question is, what do you sample? New Relic helps answer that question for you by sampling a lot of the slowest ones. And for the record, I'm not saying nice things about New Relic because I happen to be here. I'm here because I really like working with New Relic. It gives you great insights and observability into your applications. Okay, so moving on, metrics. Consider doing things like time series metrics to track system statistics such as CPU usage and memory usage. I mentioned that we have an authentication service at Lending Club, so we track number of logins over time. Those time series metrics can be really useful. Tracing is a really important one. In the old days of the monolith, you would take your debugger or your profiler, hook it up to the monolith, and you could see all the calls that are taking. When you have microservices and a distributed architecture, that just doesn't work anymore. You can have one microservice and it looks perfectly healthy, but the calls that are sending to another microservices are causing outages. You need the ability to trace through all those different microservices, every leg of the call. And there's some third-party tools that are really good for this. We actually built our own in-house called Correlation ID, but there's a tool called Zipkin, which is great for this. I encourage you to check it out. But New Relic also recently introduced support for distributed tracing, which is a very powerful tool. And Alistair, who's speaking after me, is going to be talking about that too. Monitoring and alerting. It's pretty basic these days too. We all need it. You need to get alerted if something goes wrong at 4 a.m., but it is critical. The final one is tools. The great thing is that even though our architectures are getting more complicated, there's a bunch of awesome tools out there that really help. New Relic, obviously, I've talked about already, but for logging, you've got Splunk, you've got Datadog, you've got the Elk stack, so Elasticsearch, Logstash, and Kibana. You've got tools like Wavefront and Honeycomb, OverOps, and again, New Relic. So whichever tool you choose, I just encourage you to master it before the production outage comes, because you want to be empowered when things go wrong, not trying to learn the tool in the middle of a production outage. Okay, going back. That's observability. With that observability in place, with the ability to tell what your application is actually doing in production, then we can actually start doing some real production testing. So what production testing will we do? Let's talk about testing around release time. And I want to clarify some terms before I dive into that. And the two terms are deployment versus release. The way I'm using those terms for this talk today, at least, is that deployment means that your software has been taken and deployed to the server, so installed on the new server in the production environment. But the key part is that it's not yet receiving live traffic. At Lending Club, we call that dark. The term blue-green deployments is the more common industry standard. But by deployment time, I mean the server's there on the server, no live traffic. The release part is when you start sending the live traffic over to that server. And so I'm going to break testing at release down into deployment, release time, and post-release time. The deployment phase, there are a couple of different ways we can test at deployment time. Configuration, smoke test, shadowing, and load test. The configuration test is really important. I talked earlier about the differences in the production environment. Configuration is guaranteed to be different in the production environment. Your database username and password better not be the same in your staging environment as it is in your production environment. That means the only place that you can test configuration is in the production environment. When that new version of your software, V2, is installed on that software in your production environment, but not yet receiving traffic, that's the perfect time to test your configuration. That's the first opportunity you're going to have to figure out if your configuration is wrong, and you're not going to affect any customers at that point in time. That being said, I actually don't know of any ways to specifically test the configuration tests. Instead, they tend to get tested with these other tests, which I'm going to be talking about. First one being smoke tests. Smoke test is basically just making sure that the application is performing some basic level of functionality. The simplest way to do that, or the most common, I think, is a health check. Health check is best practice in most microservices these days. It comes out of the box with many microservice frameworks, such as Spring Boot, for example. You go to /health, and it gives you a bunch of useful information about the application, such as the version ID, the git commit hash that it was built of, the build time, the server start time, and any command line arguments that were passed in when the server started up. Really useful information for debugging. But you can take smoke tests a step further and perform some basic tasks on your application. Can you log in, for example? At Lending Club, we issue loans. One of the first smoke tests that we always do is see if we can apply for a loan using some fake social security numbers. We make sure we can make it the whole way through our our loan application funnel. The next thing is shadowing. Shadowing refers to taking a copy of your live production traffic, directing it to your new dark server. You might say, well, is the server in production and now it's receiving live traffic? How is that just not a release? And the answer is that it's not sending responses back to your client. You get to see how your server reacts under that live load without actually affecting any of your end users. Again, you need to be really careful about side effects here. If you've got a bunch of writes going to the database, you need to make sure you can isolate or maybe stub out those writes. But it's good to have that live traffic going against your server to make sure everything looks okay. The next one is load tests. So you should definitely be doing load tests in your non-production environment. You can do that using testing tools. We use Gatling, for example. But it's great to see it under load in the non-production environment. That's not to say you can't do it in the production environment too, because again, there are so many characteristics unique to your production environment. There's no reason you can't load tests there too. And you can combine the load tests and the shadowing. For example, take a copy of your live production traffic. Let's say it's usually handled by a set of 8 servers. Reduce that down to 2 servers and put the production load against it. How does your application handle it? A great way to see what your breaking point is. Are you CPU bound, for example? Are you going to run out of memory? Because at some point in production, you will have more traffic than you expected. It's nice to know what's going to happen in that scenario. So another example of testing at the deploy phase in the dark server before you actually go live. Let's say you've done all of these tests. You've deployed the software to the server. It's in the production environment. You've gone through smoke tests and all the other tests, and everything looks good. You're ready to release it. What testing can you do at that release phase? 2 main options: Canary releases and internal releases. The Canary release is, rather than saying, okay, everything's ready, let's put all of the production traffic onto the new version of the server, taking a small percentage of that traffic, for example, 1% onto the new server, gives you a chance to see how it starts reacting to that live traffic without affecting too many users if things go wrong. You may affect 1% of users, but that's okay. Not ideal, but it's better than 100%. The internal release, I think, is actually even better. So that's in the production environment, receiving traffic, but it's receiving traffic only from your internal team. So internal traffic, your employees, essentially. And this is something we do at Lending Club. Your internal employees are way more motivated to tell you there's something wrong with your application. In fact, they probably may have introduced the bug themselves. So people will want to tell you when something's not working. You'll get feedback really fast in the real production environment. And then if everything looks good, you can go Canary release and then full release. So that's testing around release time. The final part of the testing around release time, post-release. So even after you flip that switch, even after 100% of the traffic is now going into your server, there's still some more testing that you can do. The first is feature flags. This is a pretty common approach to testing in production these days. You may not even think of it as testing in production, but it definitely is. Feature flags are deploying code to your server, but it's not enabled. So it's not being executed at runtime. We use these for several different reasons. The first is to coordinate releases across different microservices. So rather than saying all these microservices need to be enabled at the same time, you can roll them out at your own pace, but then turn the feature flag on so all the features get enabled at the same time. Another option is to enable continuous integration. So you're working on a feature, it's not quite finished, you keep it on a long-running feature branch, which is a terrible idea. You want to do continuous integration. You want to get it merged early and merged often. So feature flags allow you to do that without worrying about it breaking production. It allows you to It allows you to have the code released, but just not active. So you can keep working on it, keep releasing it, keep merging it, and only when it's ready do you feature switch it on. And then the final use case that we have, which is a little bit unorthodox, is that we use feature switches to isolate ourselves from release date. If you're using continuous deployment, awesome, good for you, multiple releases a day, great. If you're on a cycle where you're doing it like once a week, for example, and the whole company is pushing their code out on that release day gets noisy. Stuff's gonna go wrong. People are complaining, they're pointing fingers. Was it your change? Is that what broke it? If your change is feature switched off, you're like, nope, definitely wasn't me. The day after the release, when things have calmed down, you can turn your feature switch on. If you say chaos at that point, it's definitely your fault. So it's a nice way to isolate yourself from the release. Okay, A/B testing. Arguably the oldest and most common form of production testing I mentioned earlier is the only form of explorative testing that I'm covering today. All of this other stuff is really validation testing. You're expecting everything to work, and the tests I've talked about allow you to validate that, to verify it. A/B testing is when you have two different forms of the software, and based on some predetermined criteria, you find out which one is best. And that can be based on something like number of user clicks, for example, or in our case, number of loan applications that we're receiving. And that takes me on to chaos engineering. We covered all the different forms of testing we do at release deployment phase, or the dark server at release time, when you're actually flipping the traffic to come into your server, and then post-release, when the server is already out on the server, receiving new traffic. It's the new reality. There's also testing you can do that. Okay, let's talk about chaos engineering. Chaos engineering, also known as release engineering. When I'm talking with engineers, I usually use the term chaos engineering because it sounds kind of cool. When I'm talking with management, I usually use the term resilience engineering because it sounds very serious and conservative. But the reality is they're both exactly the same thing. And they both mean that you're doing planned experiments designed to reveal weaknesses in your system. Chaos engineering is not introducing chaos into your system. Chaos engineering is exposing the chaos that's already there and you didn't know about it. And you're now learning about it in a controlled way rather than at 4 o'clock in the morning. Game days are the practice of chaos engineering. So chaos engineering is the theory. Game days are how you actually carry out chaos engineering. The exercises that you carry out with your team to perform chaos engineering in your production environment. An exercise where we place systems under stress to learn and improve resilience. We've been practicing game days at Lending Club, and it's been working really well for us. And so I'd like to walk through some of the steps that we've taken as part of the game day exercises that we've carried out to validate that our production systems are working the way we expect them to. And again, this is all about validation, right? Let's say, for example, you have service A and it's calling service B. Your theory might be that if you take service B down, service A can continue to operate. The type of theory you'll come up with. If you think that you take service B down and service A will also break, that is not a game day experiment. That's just going to break production. You want to step back. You want to take some time to set up some sprints to make sure you have that resilience in place. Then do the chaos engineering experiment. When you're sure that it's going to work when something breaks, that's when you do the chaos engineering. If you're not sure it's going to work, you're not ready for chaos engineering. But you still need to validate it because even though you think it's all going to work, until you actually break it in production, you never can be sure. I want to make this point, and it's arguably the most important point I want to talk about game days, that just getting the team together to discuss resilience can be very worthwhile. If you ask the team about the different ways they think you can break your application, that usually results in a very spirited conversation. Everyone's got loads of ideas about how the system can break. And then you say, okay, can we go ahead and break that in production? And they'll be like, whoa, well, wait, well, first of all, we need to do A, B, and C. And that's the benefit of game days. It makes people start thinking about what will happen when things break. Even if you don't get as far as actually testing it in production, preparing to test it in production is incredibly useful. And I'd like to give an example of that. We have an encryption service at Lending Club, and it uses a KMS, a key management service. So we decided we'd like to try and kill one of the KMS servers and make sure our encryption continues okay. The question is, what's okay? How do you know your system is still healthy And we thought, okay, well, probably the number of crypto operations. If that remains steady or the usual pace, things will be good. And then we realized we didn't actually know how to measure the number of crypto operations taking place. And that might sound crazy, an encryption service where you don't know how many operations are taking place every day, but there's so many, we don't log them. It's like billions a day, and we never had a metric on it. And I guarantee that if you go back to your team and you start talking about game day experiments, you'll realize you've got big holes in your metrics too. You realize that you have a bunch of dashboards that you need to create to be able to figure out if things are okay when you start breaking things in production. And that's the benefit of these game days. If you start doing game days, you'll realize that you have a ton of work, that you're going to have to set aside sprints to start improving your monitoring and your observability, and that's a good thing. How do you measure whatever your state is that you think reflects good? At Netflix, for example, their steady state is defined by starts per second, so the number of users who are clicking start on a show. And sure, that varies throughout the day and throughout the week, but it's pretty consistent per week. And so anytime Netflix carry out QASA experiments, they look at their starts per second metric. And if they break something on purpose and the starts per second starts to drop, they know something's gone wrong. So they know something's gone wrong, so they start rolling back the test. So you need to think about what your steady state is, how you measure that steady state, how you have insights into your application. So if that whet your appetite, if you're interested in doing game days, these are some of the steps that you need to do to carry out a chaos engineering experiment in production. Number one is come up with your hypothesis. And your hypothesis is almost always, if I break X, things will still be okay. Again, if your hypothesis is I break X and things are going to start going wrong, then that's not a chaos engineering experiment. You're not ready for chaos engineering. You need to think about resiliency first. And you need to think about the steady state. What does okay look like? And if you haven't thought about what okay looks like before, that's a great place to start. Well, let's assume you come up with a hypothesis. For example, if I take out my database, I can still continue to serve traffic. And you know what your steady state is, perhaps the number of visitors getting responses from your site. Then you can move on to minimizing the blast radius. So what is the blast radius? The blast radius is how much stuff you can mess up. So when you're conducting a QASA experiment, think about how badly it can go wrong. How much stuff can you mess up here? Like if you take out something, are you going to stop all of your customers accessing your site? Because that's a really big blast radius. You want to start as small as possible. And I hope this is obvious. Start in non-production first. But even in non-production, you should be starting small too. So the encryption service I talked about earlier, yeah, we have a non-prod version, but that's used by every developer within Lending Club. So if we do break that, we're affecting all 450 developers or whatever it is we have. That's a lot of people to be stopping by my desk complaining. So that's a big radius, blast radius already. Try and minimize it further. Instead of taking out an encryption server that's used by the whole company, try and set up one of your services to talk to one of those encryption services and take it out. That way, if you do mess up, the only thing you've affected is one service, which is a much smaller blast radius. You should also think about how you can, so building confidence in the resilience of the system. You should also think about, again, worst case scenario, if it does go wrong, how do you stop it? Imagine a big red stop button that you have just in case things do go wrong. Maybe you got it wrong and your blast radius is much larger than you thought. You need the ability to stop that test quickly as you possibly can. Again, an example of that is that when we were taking out one of our key management systems servers, instead of shutting the server down, which would then require a restart if things were going wrong, which can take like 60 seconds or even 2 minutes, we just removed it from the VIP pool. And if we needed to add it back into the VIP pool, that takes like a second. So that's an example of the stop button being much easier. So after we tested removing it from the VIP pool, then we did test taking it down also, but baby step into it. The next step after you define the blast radius is to actually run the test. Here's my suggestion on running the test. One option might be to do it out of hours when traffic is quiet, right? Maybe you have a consumer site and traffic is typically quiet around midnight to 2 a.m. and you'd think that might be a low risk time to do this. My recommendation is to do it between 9 and 5, even if you have a lot of traffic at that point, because if things go wrong, you want the full team around you. You want the ops team to be available. You want the DBAs to be there in case something goes wrong. And announce it to the company that you're going to be doing this. That way you've got the full support network around you. And if you get pushback from management, which you may do if you explain it poorly, the way I suggest you justify it is that you're going to be breaking stuff in production, stuff that is going to break anyway, guaranteed, no doubt about it. This stuff will break whether you do it or not. The difference is that you're breaking it at 10 o'clock on a Monday morning with the entire team there, huddled around a bunch of monitors and dashboards, and they've got all the metrics up. You know why it broke, and you can see the effect of it. That's a far cry from it breaking at 4 o'clock in the morning when everyone's sleeping. So you're breaking it in a way that was going to break anyway, but in a very controlled manner with the whole team there to support you. The next step after you run the test is to analyze the results. Was your hypothesis correct? When you broke X, did the system continue to operate the way that you expected to? The chaos experiments or game day exercises that we've conducted at Lending Club so far, our hypothesis has been correct so far. The thing is, we still learned a bunch from it anyway. For example, when we took out one of our servers, the rest of the application continued to operate just fine. But we saw a bunch of errors in the logs that we'd seen a ton of times before. We weren't sure why they were happening. And then we found out. We get those specific errors when this specific server goes down in this specific configuration. That was a really good learning exercise. We were able to add those errors to our runbook saying, if you say this, it's probably because this server went down. Whereas before, we just weren't quite sure. We knew things kind of continue to operate okay. Again, every system is never healthy, but we weren't sure what those errors meant. So even if you prove your hypothesis to be correct, which hopefully you will, you'll still learn a lot from running these game day operations. The final step is to increase, repeat, and automate. What I mean by increasing the blast radius. You may start off with one server in non-prod, you then expand it out to one server in prod, you then expand it out to multiple servers affecting multiple services, and you keep building up until you have more and more confidence in your system. The automate part is really key. So I've mentioned Netflix a couple of times, and the reason Netflix introduced, one of the reasons they introduced chaos engineering at Netflix is that hardware outages are a pretty rare occurrence. So take an AWS EC2 instance. How often does that fail? I mean, I don't know, every 2 years, maybe? That's a pretty long time. Long enough for a developer to definitely not pay attention to that when they're writing code. So infrequently that if it actually happens in production, it's pretty justifiable to say, the server crashed and we just had to restart. Your boss is probably not going to fire you for that. But if you start making that happen regularly, use something like the Netflix chaos engineering tools to kill those servers automatically in production every week, your developers have to start paying attention to that, right? It's happening so frequently that they can't just ignore it, that it's no longer acceptable to say, the server crashed, because you know the servers are going to crash. So that's what I mean by automate. Start doing this stuff regularly in production. So I talked earlier about killing our encryption service. Start doing that regularly. And there's a whole bunch of different ways you can think about how you do that, right? Do you just shut the server down? Do you pull the plug? Do you do a kill -9? Do you remove it from the VIP pool? Lots of different options, but you should be doing it regularly. That's going to get your developers' attention. They're going to be forced to think about resiliency when they're writing the code. That's why the ultimate goal of chaos engineering is to be routinely, regularly, and without announcement, killing things in production. So it's not like you're doing it 10 o'clock every Monday morning, you're going to kill the server. It'll happen randomly throughout the day, and you should get to the point where you just don't care anymore because you know it's resilient. You know it's going to fail over. You know you've got that safety built in to your system. So any questions on the game days? No? Yeah, after. Yep. So I'd say if you do have the choice between pushing when the system, breaking things when the system is quiet versus when it's busy, take the quiet one. However, make sure it's during working hours. And if things are always busy during working hours, then just accept that and still doing it during working hours, because the benefit you get from having the whole team around you vastly outweighs the lower risk from the lower traffic. So sure, quiet is better than busier. Team around you trumps all of that. What do you have in place? What do you have to have in place to start doing chaos engineering? It's observability, and that's the reason I talked about it very first. You've got to have the logs, the metrics, the monitoring, the dashboards, the tooling that allow you to see what your application is doing, that allow you to answer questions like, is it my service, or is it the upstream service, or the downstream service? Why is it running slow? Is it because I'm running out of memory? You need to be able to answer those questions, and you need to be able to answer the questions that you haven't even thought of so far. That's what makes observability difficult. Logging, you're typically logging for things that you expect to happen, right? I expect an exception will get thrown at this point in the code, so I will log that. Or I expect that we may get an undefined value passed in at this part of the code. Logging is useful, but observability is what allows you to answer questions that you've never even thought of before. That's a really hard thing to do, which is why observability is difficult. But to answer Arthur's question, you have to have some form of observability in place before you can start doing this. Okay, so I'm going to wrap it up, and then we can have some more questions. We talked about observability as the foundation for any testing in production, the ability to answer those questions that you may have in production at runtime when it matters most. Distributed architectures are really difficult. It makes it very difficult to start troubleshooting stuff. You need to have that observability in place, something beyond just monitoring and alerting. You need that tracing also. You need the debuggability. You need to have the tools built around it. We then talked about testing at release. The 3 different phases, so the testing at deploy phase, or the dark servers, as I talked about, where the server has the new version of the software, but it's not receiving traffic. You can do your config tests, your smoke tests, perhaps load testing, perhaps shadow testing. At release time, you can start doing internal releases, which are a great way to see the application running in the production environment with traffic, but only affecting your internal users. Or you can do Canary releases, where you have a small percentage of traffic going to the new version of the software, rather than doing a big bang approach. And then even after all the server software has been released and it's live and it's a new reality, there's still more testing you can do with the A/B tests, for example, and with feature flags. And then ultimately, you can move on to chaos engineering, where you're testing in production and deliberately breaking things, or at least deliberately taking services out, but in the hope, not in the hope, in the belief that things are still going to work. So one last example on a chaos engineering experiment before I hand it over for questions. On the authentication service that we have at Lending Club, we validate the tokens that get passed in on every single request to make sure that you have a valid session. And we store those tokens in a high-speed memory cache, Redis. If Redis goes down, or I should say when Redis goes down, which it inevitably will, we have a database that we fall back to instead. Database is much slower. That will impact user experience, but things will continue to work. They can continue to log in. They can continue to access the application. So a great chaos experiment is to kill Redis in the production environment to make sure that things do fall over to the database. And we've done that, and things keep working great, which means that when Redis does finally fail, I won't have to get paged at 3 o'clock in the morning. And that's kind of what we're all aiming for, to get good night's sleep by testing in production. Okay, that wraps up my talk. Any questions before I finish? I put everyone to sleep. No? Good? Arthur tells me I just hit my time limit. It's perfect. Yeah? So I think the whole goal is to make your organization more mature by doing game day exercises. Our organization was not mature enough to do chaos engineering. We are not Netflix. Like most of us aren't working at Netflix or at Google. We are not in a position to start randomly killing servers in the production environment and everything be okay. But that doesn't mean you can't start. And we started with really small baby steps. Like I said, we realized we had some really basic metrics that we needed in place before doing game day or chaos engineering experiments. And so that's where I suggest you start. You may think, yeah, we're not ready for this, and that's probably true, but you can get yourself way more ready by starting to think about A, ways that your system can break, and B, how you detect when the system breaks, and then C, how things look not broken, how you define healthy, how you define good, how you define the steady state, and putting metrics, dashboards, and alerts around your system to be able to tell those things. So you can ease yourself into this. I actually don't think that not being mature is a reason to not do chaos engineering. Lending Club, great company, but there are many ways we're not mature too, but it doesn't mean you can't start down that path. Sure. Any other questions? All good? Great. Thanks, everyone.